now let's yeah, this is the final topic, which is the mean of random variable. So I have already told you guys that statistics is all about averages and expectations. So you must be hearing this word for the first time, at least in this program, the word expectation. So the average measure, or the measure of central tendency in context of probability theory, is defined as the expectation of a random variable, which tells you the what the mean of that random variable, right? So we define that as expectation of this random variable capital X. So this is a measure of the average slash center slash location slash level of the distribution of capital X, and this is called as the expected value or the expectation of X, or in fact expected value or mean of X, and this is denoted by mu. Okay, so in the case of uh, in the case of discrete random variable, where capital X is a discrete random variable, so we'll do the simple summation. So here we'll multiply small x to the uh, PDF of this discrete random variable. This will give us the expectation of this particular random variable X. And in the case of a continuous random variable, so this will be X multiplied by the PDF of this particular continuous random variable between these interval minus infinity to infinity. And this will give us the expected value, or what we also call as the mean of that random variable. What is the measure of central tendency, or what is the average value that X will take? So this is technically called as expectation or expected value of capital X. Okay, so we'll take example. So in the case of rolling a die, okay, so maybe what I'll do, I'll just yeah. So just give me a second. So right, so maybe I can just clear the last slide. Okay, so all right, so let's see. So in the case of rolling a die, so your random variable can take 6 possible outcomes when we define that that random variable is the number that comes when we roll a die, right? So firstly, our sample space in this case is 1, 2, 3, 4, 5, 6, right? And our random variable X is defined in this way. So X of 1 is 1, X of 2 is 2, right? That is the number which comes up, right? So each of all these are possible outcomes, and this is how we are defining our random variable, right? So this is the definition. So this is essentially for the outcome 1, our random variable will take the value 1, right? So this is essentially a, a way of just calling this mapping. Okay, so now we want to find out the expected value of this, right? So let's draw the table, right? So this is your X, and of course you have here P of X is equal to small x, and your X can take value 2, 3, 4, 5, 6, right? So and all these probabilities are 1 by 6, 1 by 6, 1 by 6, right? Because each number is equally likely to come, right? So you're not dealing with a biased die or a die made out by Shakuni Mama, right? So this is a fair die, right? And then so expected value of X will be simply sigma of X multiplied by probability of X is equal to X. That is our probability density function, or sorry, probability distribution function. So okay, so what we can write here, so if X is taking a value 1, right? So what is the probability? So that is 1 by 6. If X is 2, what is the probability? Again 1 by 6, something like this. And then here we'll have 6 into 1 by 6, right? So if you calculate this, this will come out to be 3.5. Okay, and this is the expected value, uh, uh, expected value of this random variable. Of course, this particular value you'll never see in real life, right? So you'll never see when you roll a fair die, that's this number comes on the top, right? That is 3.5. But the expected value we can calculate and measure, that the expected value of this particular random variable is 3.5, right? So this is how we define the expected value. We'll be talking about expectations, expected value a lot in detail, in fact, in the coming few days. So I'll go through these concepts in detail, right? So, and then for continuous random variable as well, you can, so this is the example that we took last time. So here also I'll just tell you how do we calculate the basically the expected value, right? So it's pretty simple. So you multiply W with the PDF, and that PDF is defined as 12W square 1 minus W. So in this case, so here you'll have 12W cube, because 1 W has been multiplied, and then 1 minus W. So if you evaluate this, this will come out to be 0.6. So what does this mean? That the expected value of this particular function, if you can see, so this is 0.6, right? So this particular, so this is this mean value. So this is of course different, but if you calculate the expectation of this random variable, so this will come out to be 0.6, right? So that is the average value which you can assign to, right? So in this case, I can annotate that, yeah, this is 0.1, 0.2, 0.4, 0.6, right? So talk about this particular, right? So this is 0.6. So this is the expected value of this particular random variable, and of course we're talking about this particular interval only, right? So this is the expected value, right? And as you can see, this is not exactly the mode, but slightly to the left of the mode, right? So as you can see here, it's 0.667, not 0.6, right? So this is the expectation or the mean of this particular random variable, and this is less than what we have in the mode, right? So I'll just clear this particular bit, right? So these are not that difficult concepts to understand, right? But once you know what is a discrete random variable, what is a continuous random variable, then you know that to any such random variable, either discrete or continuous, you can define a probability distribution for that random variable, because essentially what's happening, that random variable is taking some set of possible values, right, which we're denoting as small x. So we can associate a concept of probability distribution for a random variable, and from there we can introduce the idea of cumulative probability density, cumulative distribution function, etc. And once we have the PDF, that is the probability density function or the distribution function, so there we can find the mean in this particular way, right? Which is essentially, in the case of discrete, we are summing up, yeah, we are multiplying x, that is the individual values of the corresponding probabilities. So this is what we'll also call as probability mass function, okay? Because in the case of discrete, and then in the case of continuous random variable, we'll call this a probability density function, okay? So here also we can calculate the expectation by multiplying the PDF with W. Okay, so this is pretty straightforward calculation, and you can just confirm it, right? So there's nothing much to worry about, right? So variance of random variable. So okay, so I think what I'll do, I'll try to cover the concept of these things, these concepts tomorrow, because I think it's already late. So from tomorrow, yeah, we'll start with the notion of variance. So we'll define variance, how variance is defined, and you'll learn that the variance is nothing but expectation of this weird looking term, right? So we'll try to dig deep into this, and I want to spend a lot of time explaining to you why we write variance, or if we say that, yeah, variance is a measure of spread of the distribution about its mean, why is this formula, why does this formula look like in this particular fashion? right? So I want to spend a lot of time on this. So we'll cover this tomorrow, and then yeah, we'll see how we calculate variance for a discrete random variable and then continuous random variable, and then we'll also talk about uh, how we can find the expectation or the variance of linear combination of random variables, right? So these concepts are very important from the perspective of statistics, because remember, statistics is all about averages and expectations, right? When we are trying to come up with a statistic, that is a representation or a representative summary of our data. So expectation is very one major concept, and expectation of a random variable is defined as the mean. Okay, so do not confuse it with the median or the mode. I'll tell you uh, how we can define median and mode through different uh, formulas, or what are the formulas for those. But expectation of x is defined as the mean. Okay, so this you must learn by heart, right? So because in the case of if you talk about the mode, right? So or you talk about the median, let's say for any such event, for example, rolling a die, right? So or for any other different experiment, the mean, median, and mode can differ. But going ahead, we'll try to will keep or what shall I say, that will keep this notion that expected value is nothing but the mean of that random variable, right? So capital X is your random variable, and because a random way to a random variable, we can associate a probability distribution. So you can always ask, right, for a probability distribution, what is the most likely value, right? Or what is the expected value, right? So there are a lot of different questions you can ask, and for those questions, different measures will come in place. So when I ask this question, what is the expected value of this random variable which follows this particular probability distribution function? So I'll calculate in this particular fashion, and I'll tell that yeah, expected value is this. Okay, even though that might not be the correct value, just as we saw here, that in the case of sorry, so in the case of rolling a die, the expected value comes out to be 3.5, but that is not the value we'll ever see in life when we roll a die, right? But that gives us a general idea that yeah, this is the expected value, right? So let me ask one very good question to you guys. Okay, so suppose you are playing a lottery, okay, with 50 friends of yours, right? And only one guy can win that lottery. Okay, so you're playing a lottery with 50 friends, as in there are 50 participants, and only one guy can win the lottery. So the cost of the ticket is 10 rupees, and if you win, uh, if you win the lottery, you'll get 100 rupees. So my question is, do you want to actually play this game? Do you want to actually try out your hands with the lottery? Find the question here. So, so, so the probability of winning a lottery. So probability of winning is 1 by 50 because you're playing with 50 friends. Probability of losing is 49 by 50. The cost of the lottery is 10 rupees, and when you win, you'll get 100 rupees. So do you think you should play the lottery, or you should play this game? So to answer this question, we can ask this question: what is the expected profit that I can make, right? So what is the expected profit that I can make? So x into probability of x is equal to x, right? So in this case, if I'm winning, so my probability is 1 by 50, and so what is the profit will I get when I win? 100. And then what is the probability of losing? That is 49 by 50. And what is the profit I am making when I'm losing? So minus 10, because I bought the lottery but I did not win, so I wasted my 10 rupees, right? So this is 2 minus, right, so 0, and then this will be somewhere around, let's say, very close to 10. So maybe 9.8, I guess. Right, I guess I'm correct, right? So this is less than 0, so expected profit is negative to play this game, right? But let's say if the uh, amount which you'll get when you win the lottery is not 100, but let's say a million, right? So maybe here, instead of 100, what I can have, let's say I can have 10 to the power 6, right? So as you can see, this number in the other case is, say, let's say if you win the lottery, you'll be winning $1 million, right? So in this case, this probability is much greater than zero, right? So that's why it makes sense for you to win, because your expected profit is way positive, right? So this is an example of how you can interpret expected value in a way.